Believe it or not, I'm not going to show you how to subtract integers in this video. I'm going to show you how to get around it. Now you'll need to remember what we did last time when we added integers. Do you remember? There was really two groups. When integers had the same sign, we treated them as if they were on the same team. For instance, the negative team and the positive team. When they were on the same team, for instance, -7 and -2, they added to each other's strengths, and we just made them more negative. -9. +7 and +2 are +9, more positive. Get the idea? -3 and -5, -8. That's easy. +3 and +5, +8. -12 and -4, -16. Just more negative. They add to each other's strengths. And of course 12 and 4 make a +16. You could also remember here that you're using the sign that's already there.
Are you pondering what I'm pondering?
To add integers with different signs, one of each, we subtracted the absolute values of the original numbers and then used the sign of the number with the larger absolute value. For instance, -5 plus 3, we subtracted their absolute values. Just forget the signs, in other words. 5 minus 3, and got a number of 2. Now, we made the answer a -2 because the number with the largest absolute value was -5. So his sign goes with the answer.
You are correct, sir.
And the answer is -2. In this problem, -2 and 6, once again, subtract the absolute values. Forget the signs and just subtract. We get a 4. Now what sign is that 4 going to get? We're going to use the sign of the number with the largest absolute value. And that's 6 in this case. That's the positive. So we don't have a -4. The answer is a +4. We don't have to write the positive, by the way. One more, -25 and 30. We subtract the absolute values because we have one of each. We get a 5. And what's going to decide whether that's a +5 or a -5? We're going to use the sign of the largest number, the largest absolute value. The answer is going to be +5. So when we add integers, we're going to end up using the sign of the largest absolute value. Because in battle, the biggest guy always wins. And now, let's talk about subtracting integers. Now, if you get confused while subtracting, there's going to be times when you're not confused. But if you get confused, for instance, in this one, I'm not confused.
I can do that, but I don't want to.
I just subtract 8 minus 3. Still, the parentheses aren't confusing me.
No problemo.
Still, 8 minus 3. Here's one when I get a little bit confused, when I see two negatives or something of that sort. What I'm going to have you do
There's something screwy around here.
is consider, what does this symbol, this subtraction symbol, or this, I shouldn't say subtraction, what does that symbol represent? Is it negative? Or is it subtraction?
Oh, dear. That's too wonderful to be true.
Well, we got some good news for you. Actually, it can be whichever one you wish. It can either be subtraction or negative. And I always tell people, always treat that symbol as a negative sign. Don't even subtract. We're not going to subtract. We're always going to treat that symbol, no matter where it occurs, as a negative sign. if we do that, we'll never have to subtract.
Hey, that's just crazy enough to work.
Remember, that sign means negative, and negative means opposite. The negative of something is the opposite of something. Okay? Now I want you to consider this word opposite.
Excuse me, Professor Brainiac.
I know. What is the opposite of an opposite? The opposite of the opposite.
Are you pondering what I'm pondering?
Well, think about a light switch. We'll start with the light switch on. Okay? If we flip it once, the light goes off. Yeah, very basic, isn't it?
Well, ooh-la-dee-da.
Okay, that's the opposite. The opposite of on is off. Now let's talk about the same light switch with the lights on. We'll start again with the lights on. And this time we're going to flip it twice. We're going to do the opposite of the opposite. The first time it'll be off, and we still need to flip it again. So the second time it ends up back on, doesn't it? Very simple.
Wait just a minute.
So you could say the opposite of an opposite will bring you back to where you started, won't it? The opposite of the opposite is a plane. Wow. It's a positive. Okay, the negative of a negative is a positive.
Excuse me?
A double negative is going to get you back to a positive, and we're pretty good with positives. So,
Why does this keep happening to me?
this problem is not going to be that bad if we get rid of the double negatives first. And I want you to consider that as a negative, not a subtraction sign. So, two negatives are going to get us back to where we started. Anytime you have two consecutive negatives right in a row, I want you to change it to a positive. And now it's easy. 8 plus 3,
It's very simple, sir.
and there it is.
I'm trying to think, but nothing happens.
How about this one? Well,
I know that, dude.
we know that's a negative.
I know you are, but what am I?
Well, this one, I told you can treat that however you want. Well, I'm going to treat that not as a subtraction, but as a negative. So I've got negative 5 and negative 13. Negative 5 and negative 13. Well, now it's easy. I'm adding two negative numbers. No subtraction here. And I'm an expert at addition. Remember when two integers have the same sign? They just add to each other's strengths. Negative 5 plus negative 13 is negative 18. And there you go. Let's do another. We've got to get rid of the double negatives first. And we do have double negatives in this case. Have to be right in a row. See the right in a row. I'm going to change every double negative to what? To a positive. Because two negatives, the opposite of an opposite, get me back to where I was. Well, now I've got a negative 8 and a 3. Do you know how to add signs that have integers that have different signs? Well, we subtract. Subtract the absolute values, 8 minus 3, get a 5, and use the sign of the biggest number. The answer is going to be negative 5. Notice we didn't have to really perform subtraction. We kind of had to, but we did the rules of addition in order to do that. Now the word difference always will infer subtraction. It's important for you to know that. Before we go to this problem, I want you to consider, I met this fella, Yao Ming. Truly, I met him. He was 7 feet tall. The man's 7 feet tall. I'm 5 feet tall. Now what's the difference? Well, if you can picture that, you know that he was 2 feet taller than me. What did you do between the 7 and the 5? Well, the difference was 2. You subtracted. So the word difference infers subtraction. Let's look at this problem. If Bill got a +3 on the last hole at Augusta, and the gentleman Tiger got a -2, what is the difference in their scores? Now, this is going to be a little bit weird. Difference, we know, infers subtraction. But there's already a subtraction there, isn't it? There's already a negative anyway.
I demand an explanation.
Okay, let's not get confused. The difference between these two numbers, the difference gives us the subtraction. The negative came from the -2. Okay? Don't lose either one of them. And when I have two negatives in a row, what ends up happening? They end up turning to a positive. The answer to this question, the difference between 3, my score of 3, and Tiger's score of -2, he beat me by 5. Son of a gun. It can happen, can't it? Double negatives. Let's look at another example.
I have a feeling some bad stuff is about to go.
You know the average temperature in Peru is 92 degrees. It's hot. The average temperature at the North Pole is -52 degrees. What's the difference between these two average temperatures? Remember what difference means. Difference means subtraction. So I take the two numbers the way they are and additionally put a subtraction sign between them. Difference means subtraction. The negative was already there. Now, I've got two negatives in a row.
Warning, warning, warning.
Two consecutive negatives turn into a positive. And 92 plus 52, let's see, it's 144. Could it possibly be 144 difference in temperature? It could be. Look at it. To get from -52 up to 92, you have to go the 52 and an additional 92, as you can see on the number line. Okay?
Not because they are easy, but because they are.
Now, what are we going to do when we have to add or subtract or combine, basically, if you would, in an additive way, more than two numbers? Well, I have a strong suggestion. First of all, I'm not going to spoil you here with the colors. I'm going to let it look like it was going to look like in the homework. All one color. Now, the first thing you should do is go through and get rid of all the double negatives. There's one. That'll become a plus. And there's one. That'll become a plus.
Oh, yes.
Now we have each number having only one sign. And a giant addition problem, basically. Now remember, it's much easier to add numbers that have the same sign than to go through the battle of numbers with different signs. So what I'm going to do is add all the numbers that have the same sign. First, I'm going to add all the positives. Let's see, 7 and 8 and 3 and 8 and 1. Those are all the positives. They all get together and make a larger positive number, positive 27. And then I'm going to add to that, whoever's left over, the negatives. And I do circle them, just like you see here. -5 and -2, that makes -7. Now, I do have to do a battle, but at least it's only one battle when you have a large number of numbers like this. And 27 and -7, I've got a battle. I'm going to subtract. I get 20, and I'm going to use the sign of the larger. And the answer will be
I know that, dude.
positive 20, because the largest absolute value is 27. Okay, so my suggestion, when you have to add more than two numbers, the commutative property is going to allow you to do it in any order. Add all the positives, then add all the negatives, then have the battle between the positives and the negatives. Only one battle. Okay? Let's get to it.
Does everybody know what time it is?
It's time for homework. Do it up.